Hi guys, this is Mr. T again, and I'm at my virtual beach again. Well, it's virtual. Oh well. But today we're going to do a little video on completing the square. And so we got this cute little diagram of two pieces of a square. They're going to be put together to make a complete square. And that's kind of the idea of what we're going to be doing. Um, so I got 7 examples I want to work you through as quickly as I can, just because I believe that maybe the more examples will be more helpful than me just yabbering here. Okay, so let's get to this thing. Okay, um, next slide. So here's our first 3 examples. We're going to start from number 1. Okay, now this is a nice one. It's just got x squared equals 12. So a quick way we can solve this just by taking square roots of both sides. And so we would take the square root of the left side, the square root of the right side, the square and the square root would cancel out. And so we get an x that would pop out. And then we got the plus or minus the square root of 12. Well, we can keep working on that because that's plus or minus the square root of 4 times the square root of 3. Oh, don't forget our x's. And then that simplifies to x equals plus or minus 2 on the square root of 3. So that's quick and easy, even with a little bit of breaking down the 12. So isn't that nice when we have a something squared equals a number or something on the side? Quick and easy. Now, in example number 2 here, we see something squared plus a number equals a number. Well, what could we do to make it like number 1? Well, if we subtracted 7 from both sides of our equal sign, that would leave us with x minus 6 squared equals negative 7. Now we have something squared equals a number, just like we had for number 1. So we can again take the square root of both sides. Okay, and our square and square root will cancel each other out, and whatever is inside plots on down to the next line. We don't worry about what to do with it, just bring it down first. Here we go. Now we have plus or minus. Well, that's not like the square root of negative 1 times the square root of 7. That's legal, right? And oh, look at that. What is the square root of negative 1? That's I. So that would give me x minus 6 equals plus or minus I on the square root of 7. Okay, so we got a little bit of imaginary number stuff going on, but it's quick and easy. So we almost got x by itself, so let's add 6 to both sides. Go from left to right, bring down the x. That does cancel. Are these like terms? No, so we're just going to write them next to each other. 6 plus or minus I on the square root of 7. Okay, and that is 2 answers because we got the plus and the minus. 6 plus I on the square root of 7, 6 minus I on the square root of 7, which is imaginary number. Okay, so number 2, the point of this is, even though we have a binomial, it's in parentheses and squared. So all we had to do was get this one number over, and we got the same basic scenario as we did for number 1. Okay, take the square roots, and then we just work with whatever collateral damage comes along the way. Okay, now example 3, I want to do this by square roots as well, but it's not like number 2 where there's a something squared. We've just got the x squared. Well, if I brought the x over, I think that's going to cause me troubles later because you got the square root of x is on both sides, all kinds of craziness. Oh, but what do we notice here? Isn't this a perfect square trinomial? So I could write this as x plus 4 squared. Remember, square root and square root. Okay, you multiply together times 2, you get 8. Yes, that's true. And look at that. So by factoring, we were able to make it look a lot like number 2 on its second step, which is a lot like number 1. Something squared equals a number. So if you can get an equation to say something squared equals a number, then we can use this solve square roots on both sides. Okay, so this is setting us up for completing the square. But let's finish off this one first. So here we go. We got our square and square root. They cancel each other. And so you're left with x plus 4 equals, what's the square root of 9? 3. So we got plus or minus 3i. 3i, because that's a square root of negative is just the same thing there, except you got to put your imaginary number on the end there, or the symbol for imaginary. All right, and then we subtract 4 on both sides, get x by itself. And so here we go with x. These do cancel. Negative 4 plus or minus 3i. Easy enough? Okay. So each one of those, so this was already, number one's a perfect square already, just x alone. This one we already had a square set up. This one we had to factor it to get a square. Okay, in our next examples, they're not going to be so great. We're going to actually have to do a little bit of work. But I do want to make notice of something here. Look at this. Okay, 8. If I took 8 and divided it by 2, I'd get what? 4. What's 4 squared? Isn't that 16? Do you think that's an accident? No. This number at the end is always going to be the middle number divided by 2 and squared. That's important as we go forward. So we need to know that this number at the end is always got to be the middle number divided by 2 and squared is what this number needs to be. And if it's not, we're going to have to make it happen. And we're good that way. We can make it happen when we need to because we're in control of these things. We know how to manipulate them and make them do flips when we need them to, okay? So we're in control. We can make that happen because we like solving by square roots. It's quick and easy, pretty much. And so we're going to give this a shot. So let's do a few more examples. Okay. So like this one here. So, there's that 8 again. And if that was a 16 instead of a 17, I could factor it, couldn't I? So I need this to be a 16, not a 17. So at this point, there's 2 different ways that people go about completing the square. They do A, they kind of leave the number sitting there, and so it kind of looks like number 2 here, and then they later on get rid of the number later, okay, after they factor it, or they can just get rid of their number, okay, and make it kind of look like a number over here and put what they want. I like the second one better, so we're going to do, but you'll see them both ways done in different examples out there. So what I'm going to do is, since 17 is not the number I want, I'm just going to move it over to the other side and see, and we can do that because it's not a person. That would be kind of rude to do to a person. It's like, you're not what I want. We're just going to get rid of you, throw you out, just kind of throw you over there. But it's a number. It doesn't have feelings that way. So we're okay. Okay, so so here we go. We got x squared plus 8x. Then we got this blank equals negative 17. So we said a while ago, we need the middle number divided by 2 squared. So what that number, so let's come down here and do some side work. So that's called b over 2 squared. And so in our case, what's that going to be? That's going to be an 8. So 8 divided by 2 is 4, and 4 squared equals 16. Okay, so that's kind of our side work over there. All right. So what do we need? We need to add 16 to both sides of our equation because we got to keep the balance going on. And now looky there, we have that perfect square trinomial happening. So now we can say this is x plus 4 squared equals negative 1. So number 4 is just almost like we did for number 3 here, okay? When we had that 16, this is what we did. So it's going to be very similar steps. Okay, so we're ready to take the square root of both sides to get rid of the square. Oh, look at that. That's the definition of I, isn't it? Okay, but let's not get ahead of ourselves. It's square and square root. They cancel. And so whatever's inside plops on down to the next line. We don't worry about what to do with it, just like a brand new cow, I usually say. You know, you don't try to clean her up. You got to get it out first, and then you start working on cleaning it up and such. And so what is that? That's going to be plus or minus I. Okay. Now we almost got x by itself, so we're going to subtract 4. Subtract 4. X equals negative 4 plus or minus I. Okay. So what reason why it's called completing the square is that we like to take square roots of both sides, but you got to have the right set of numbers to make that happen. So since 17 wasn't cooperating, we got rid of it to the other side, tossed it to the side, and then we said, okay, let's take this middle number here, divide it by 2 and square it, because that will give us a perfect square, thus completing the square. Okay, so that's all we're doing is forcing this scenario to happen. Okay, let me see. So big guy here. Okay, so what we're doing is we're forcing this scenario to happen. Okay, that's what completing the square is all about. All right, so let's go here. So we're wanting to do complete the square on this one, and 7's not cooperating. That's not going to be very effective. So what we're going to do is we're going to say x. Whoops, let's back up just a little bit here. Let's go ahead and get rid of this 7 first, since we already got a 9 over here already. So let's I'm not sure. I think that may have been supposed to be in a 0. Yes, that's supposed to be a 0. So that's what's going wrong here. Okay. And this is supposed to be a big old 0. There we go. Perfect 0 now. That's just a typo. So now we've got x squared minus 2x equals negative 7. Okay. So I'm going to come down here and do a little bit of side work. And we said it's b divided by 2 squared. So in our case, that's going to be negative 2 divided by 2 squared. So negative 2 over 2 is negative 1. And you square negative 1, you get positive 1. Okay, so we're going to add 1 to both sides of the equal sign. Okay, so I'm going to factor this guy. So it's going to give us x minus 1, because we got that negative there, squared, equal negative 6 in this case. So again, what have we done? We have forced this step to happen. That's what completing the square is all about, is making this a perfect square so that we can just take square roots of both sides and go from there. Everything else is just collateral damage, finish the thing off. Okay. So bring out the x minus 1, and then this is going to be plus or minus I on the square root of 6. Okay, because we can't do anything with the 6. We can pull out the I, pull out that negative, and then add 1, add 1. Okay. So we have completed the square on 2 examples. I'm going to do 2 more examples. This gives you a pretty good idea. But stay tuned. The very last example's got a little twist in it. Okay. All right. So 2 more examples here, just to kind of walk you through. So again, we're trying to factor this. Can't happen. So we're going to get rid of our 7. Add 7 to both sides. And if this was a number, we just add whatever it is to it. Other than 0, we would add 7 to it, whatever it is. That doesn't really matter. Okay, so now we have x squared plus 10x, I'm going to leave some space there, equals 7. Okay, so again, we said we're going to take this b version here, so it's b over 2 squared. And we noticed that earlier, right? So this is not, again, this is not just some generic formula that we came up with. We said this earlier, that the reason why number 3 could factor is because 8 divided by 2 squared is 16, and it will always be the case. So we're creating that scenario to happen. Okay, so that's where this b over 2 squared comes from. It's not just pulled out of the air. Okay, I know a lot of times y'all guys think that that's all math teachers do, is they just pull numbers randomly out of the air. Now, for examples, maybe I'll just make up numbers because we can make them do tricks. That's fine, but they have to be in the right scenarios. So 10 divided by 2, that's 5. 5 squared, that'd be 25. So here we go. We're going to add 25 to both sides. Right. I get sometimes nervous when I'm at the house and I don't have people watching me, because I make mistakes sometimes, just like you do, and there's nobody to catch my mistakes. Like that one. I caught that one. Okay, that's supposed to be square root, so that's a 5. And by the way, didn't you notice that if you take b over 2, that's always that number? If you haven't noticed that already, yeah, this number in here is b over 2 without the square, because see, there's your square part. Okay, so now we're going to square root, because we have created a perfect square. Okay, the square and the square root cancel. So it leaves us with x plus 5 equals plus or minus the square root of 32. Okay. All right, kind of put that off to the side. Let's break down our 32. So x, well, to draw that back in, got carried away. All right. So this is plus or minus, let's see. Oh, 2 times 16. Doesn't 16 go into 32 twice? Yeah, and 16 is a perfect square. Isn't that good? So square root of 16 times the square root of 2. That's still 32. Good. That'll work out nicely. So we still got x plus 5 equals plus or minus 4. Just plain 4, right? Once you take it out of the square root and do the square root, you don't put it back inside the radical sign. And then we subtract 5 from both sides. So it's not so bad. So here we go. And that's negative 5 plus or minus 4 times the square root of 2, or 4 on the square root of 2. Okay, so we got one more example, and this one's got a little bit of a twist to it, okay? And but don't be afraid, it's only got a fraction in it, and we're not afraid of fractions because they're our friends. Yeah, I know better than that, but here we go. Let's give it a shot. So here's number 7. Something we haven't mentioned, but something we always need to be doing is we always need to be checking if there's a common factor, right? Is there a common factor? Yes, there is. So we could rewrite this as pulling out the 3x squared plus 3x minus 2 equals 0. We could do that, and then we could divide both sides by 3. And that would just leave us x squared plus 3x minus 2 equals 0, wouldn't it? Okay, and that's true. And that, but you know what? It's nice when we had a common factor, but here's the deal. With these kind of problems, I don't care if it is a common factor. We can't do completing the square with something out front that's not cooperating. So here's what we're going to do, okay? So while that was completely correct what we just did, I'm going to go back a little bit and just say, hey, let's, and in this case, we were able to factor out a 3 out of all 3 parts. But the truth is, when it comes to the completing the square, it really doesn't matter what's, if it has a common factor or not. Whatever's in front, you divide everything by 3 right off the bat. Okay. Now this still gives us the same information on the next step for in our case, right? This still gives us the same information. But when you have a number in front of the x squared, you just divide it out because we got to have an x, 1x squared for this thing to work. It's not going to work otherwise. Well, we might can think of a scenario, but that's not for today. All right. So the whole, we're trying to complete the square. That means, so 3 divided by 2 squared, is that negative 2? No, it's not. So negative 2 is going to have to go away. It is not helping us. So we're going to toss it off to the other side. Again, you aren't supposed to treat people that way. Just saying, just reminding you. But these are numbers. It's okay. Okay. Wife's doing laundry right now. All right, so back to where we were completing the square with this last little crazy thing. So here we go. It's going to be b over 2 squared. So that means it's going to be 3 over 2 squared, which is 9 over 4. Oh, yucky ducky. But okay, here we go. That's no, we're going to live with this and be just okay. Okay, this is just side work. So here we go. Fractions are our friends, right? We're having a positive attitude. Plus 9 over 4, plus 9 over 4 on both sides. And now we can factor, so we can take the square root. Square root. How do you take the square root of that? Well, what's the square root of 9? 3. What's the square root of 4? 2. And remember, just like what I told you a while ago, this part inside here is always that number. Okay? So don't go getting all uptight too bad because you already knew what the number is going to be. Just because it's a fraction, we can live with that. Now, what's 2 plus 9 over 4? Okay. Well, let's see here. Let me quit out of here. So 2 plus, y'all get all uptight about these fractions. We got this nice fancy calculator. Let's let it do some work. And we said it was 9 over 4. 17 over 4. So, okay. So 17 over 4. Easy enough. And now we're going to take the square root of both sides, just like we always do. Okay. And then whatever's inside plots out to the next line. Equals plus or minus the square. Well, let me do this. Let's break this up into the square root of 17 over the square root of 4. All right. So let's bring this up a little bit more. Get me over here out of the way. That was kind of discombobulating, moving around like that. Oh my goodness. Oh well, I'm just being silly. All right, here we go. That's so surprising to y'all, right? So let's keep on going. 3 over 2 equals plus or minus square root of 17 over 2. So now we don't have to rationalize the denominator, which is good news. All right, we're almost there, folks. We're almost there. We are quickly coming to the end of our completing the square ride. So just hold on. Here we go. So this is x equals negative 3 over 2 plus or minus the square root of 17 over 2. Or we could write that as negative 3 plus or minus the square root of 17 all over 2. Either one of those would work just fine. Okay. Either way, we're good. Give me a highlighter here. We'll put this in highlight. Woo! So what did we do? So let's see if we can jump back up here. So we noticed that taking square roots is real easy. And if you have these perfect squares in here, that's nice with number 2. And then if you can factor in, get a perfect square. But sometimes they aren't so nice. And so what we have to do is trash this number and then create a perfect square. And then we can take square roots and go from there. And that's what we did with each one of these problems. And so let me get my head of whoa, here we go again. Okay, so we're completing the square. We were trying to create that perfect square. And so by doing so, we put the two pieces back together and now we have completed the square. Um, Hope that's helpful to you to see several examples. Let me know if you have any questions and have a good evening.